Good day everyone, welcome to my class again. This will be the continuation of the discussion that we have regarding significant figures, scientific notation, and conversion factor. And this time, this will be the part 3 of our video lesson. Once again, I am Mr. Muhammad Simpal, your physics teacher from Esperanza National High School STEM Department. Let's go to the scientific notation. Scientific notation, class, is a compact way of writing down a very small and very large number. Sometimes we are bombarded by numbers, no? In our laboratory experiments, and most of the value that you will be encountering in this lesson or in this subject can be related to the application of scientific notation, because we're dealing with very large and very small number that we cannot afford to express it without applying a scientific notation. Okay. What are the steps in scientific notation? For number 1, transfer the decimal point to the right or to the left so that the decimal point will just be immediately after the first non-zero digit. We then have the value of n, which is between 1 and 10, and n will have as many significant figures as there are digits in n. N here, class, is referring to a given number, any number. Okay, how are we going to do this one? Transfer the decimal point to the right or to the left so that the decimal point will just be immediately after the first non-zero digit. For example, scientific notation step. Maybe I should use blue. Step 1. Step number 1. For example, we have this series of number 50000. Now, how do we express this one in scientific notation? According to the first step, transfer the decimal point to the right or to the left so that the decimal point will just be immediately after the first non-zero digit. Our target here is to convert zeros or to transfer the decimal point. Obviously, the decimal point of this series of number is located here at the end of that zero. Now, for step 1, we will transfer the decimal point, this one, we will transfer the decimal point to the right or left as long as non-zero digit or after the non-zero digit. That is step number 1. How do we do that? Obviously, from here, 1, 2, 3, 4. So I will just stop here because according to our rule of step number 1, we will transfer the decimal point either be to the right or to the left. Our target is so that the decimal point will just be immediately after the first non-zero digit. So since this is non-zero digit, so we will stop here after the non-zero digit. Now, for us to express this one in scientific notation, we will count how many decimal point or how many movement do we have from this point to that point. Okay? We will just count 1, 2, 3, 4. So, we move 4 times. And this 4 now will be the exponent. Will become the exponent of this given number. So to write this one, it becomes, I can write this as 5 times 10 I will rewrite this one. 5000 is equals to 5 times 10, or I can express like this, 5.0 times 10 raised to 4. So this is now the expression of this series of number according to step number 1. Let's go for step number 2. For step number 2, the number of places the decimal has been moved is equal to the integer n. This integer or exponent often is positive if the decimal point is moved to the left of its original position, and n is negative respectively. Okay, how are we going to express step number 2? I will just present this scientific notation step by step, and maybe I will give you another example combining these two steps. So for step number 2, for example, we have a series of number, like for example 54000. We have the decimal point located here. So all we need to do is to move this one right after the first non-zero digit. So from this one, 1, 2, 3, 4, 5. So how many movement do we have? We have 5. It becomes 5.4 times 10, number of movement, 5. So this is the expression for this series of number. Another example is, if we have here, that's positive 5. If we have here 0.1, 2, 3, 4, 4, 5. So the decimal point is located here. Again, same rule. We will transfer decimal point right after the first non-zero digit. So from this one, 1, 2, 3, 4, 5. And I'm gonna stop here. So this becomes 4.5 times 10. This case, since this decimal point is located here at the left side of the first non-zero digit, and we move it here, this becomes the negative here. How many movement? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have negative 5. Why negative 5? It's because we call this one as this number here as boundary. I'm gonna explain it. As long as the decimal point will not cross the boundary, like for example this one, this is the boundary. As long as the decimal point will not cross this boundary, this whatever the movement or the direction of the movement of decimal point you have made here, still the exponent is positive. While when the decimal point is before the non-zero digit, whatever movement or the direction of decimal point movement you have made here, the exponent is still negative. Here the exponent is positive. How about if you cross this line? If you cross this boundary line, we will trace the origin of the decimal point. If the origin of the decimal point is from this corner before the non-zero digit, and it crosses the boundary, for example, it is still positive. Okay? Why? It is still positive, but you have to subtract how many numbers or how many movement you have made right across this boundary. So that is the concept of that. We have example of that for you to understand it more deeply. For example, we have here, we will switch on the presentation. So let's try to familiarize first step number 1, because we will combine this one, and I will show you the example of combining these steps and also the crossing boundaries of the decimal point. What will be the proper expression of that? So you try to familiarize first. For step number 1, we will move decimal point right after the non-zero digit. And for the step number 2, the exponent of integer, or the exponent of the scientific notation, the sign for the exponent of that scientific notation, depending on the movement of the zero. Okay, so for example, okay, here we will just combine those steps. Example, we have a series of number, like for example this one, 5.5400 and 0.000, let us say 45. And another also example here, 54 times 10 to negative, let us say positive 4, sorry, positive 4, positive, or I will make it like this one, 543 times 10 raised to, shall we say, positive 3. So let's answer first example number 1 and example number 2. For example number 1, we'll move decimal point from this one, 1, 2, 3. So this is, since still in the right side, this is 5.4 times 10 raised to positive. How many movements do we have? We have 3 movements. And this one, the decimal point is here. So we will move from this one, 1, 2, 3, 4. So we have 4.5 times 10 raised to negative, how many movement? 1, 2, 3, 4. Negative 4. How about this one? If this is 543 times 10 raised to positive 3, the rule is the decimal point should be at after the first non-zero digit. So obviously the decimal point is here, so we'll move this decimal point after the first non-zero digit. All you need to do is 1, 2. So this movement now, how many movement do we have? 2. This movement now will add to the existing exponent of that series of that scientific number. So this becomes 5.43 times 10 raised to 5, or raised to positive 5. So these are the closer look or the examples on how to write scientific notation. Expect more activities on scientific notation. I will be sending this one into our Google Classroom. Now, but for now, let's move on to, if you have some clarification regarding scientific notation, let me know in our group chat. So this is scientific notation. This is how we express number into scientific notation. Let's proceed to conversion factor. We'll just erase our whiteboard here. We'll just clean it. So let's go to conversion factor. Now, conversion factor is a way of changing unit from one unit to another. Basically, we are using conversion factor if we are changing unit or expressing unit from one set of unit to another. So how are we going to apply conversion factor in our measurement? But first, before we apply that, let us have to be familiarized on the basic quantities and its value of measurement in different units or particular units. So we have basic fundamental quantities. Obviously, we have length, mass, and time. For length, 1 inch is equivalent to 2.54 centimeters. You can copy this one, or you can post this video for you to familiarize this value here. And for mass, we have here 1 kilogram is equivalent to 1,000 gram. Post the video for you to look closer and familiarize on the value or conversion unit value for mass. And for time, 1 minute is 60 seconds, and 1 year is 365 and 1/4 days. So these are just a some of the units and constant value for each of the unit that we have. We have a lot of units in particularly in our university physics in measurement, but we will consume a lot of time if we discuss or if we present all of those conversion factors here. So for you to give some of those, we have here. You can post the video and try to familiarize. We have steps in conversion factor. Step 1, in all calculations, write down the units explicitly. You have to take care of your unit class because unit is very important in physics. In physics, unit is very essential in expressing your data. So be careful of that. Step number 2, treat all units as algebraic quantities in particular. When identical units are divided, they are eliminated algebraically. That means quantities can be like variables. Same units can be cancelled out, etc. So we will treat unit as algebraic quantity, as what step number 2 emphasize. For number 3, check to see your calculations are correct by, of course, verifying that the units combine algebraically to give the desired unit. Yes, it is very important that we will verify the result of that conversion unit if we really follow the rule for cancelling or for combining units algebraically, since according to step number 2, we will treat units as algebraic quantities. Now, to further explain that, consider this example. Let us have this one. For example, 10 inches or centimeters converted into will be converted into inch. Example number 2. Another example here. This is 1. This is 2. For example number 2, let us try 1/14, or I don't have a calculator, so we will just use a exact number. For example, I have here 100 centimeters. I have here 100 centimeters, and also will be converted into meter. So all you need to do to answer number 1, let us have to list the given. First, we have to list the given. 10 cm. We will try to go back to the conversion unit and try to find the direct relation of centimeter to inch if we have direct relation. For example, inch to centimeter, so we have a direct relation. That means I can put here 1 inch is equivalent to 2.54 cm. So this is my basis now. Now to do this, we'll just have to put 10 centimeters times we will treat a unit as algebraic function or quantity, That is why for us to cancel out centimeter to centimeter, we will put centimeter here. So for every 1 inch, this is equivalent to 2.54 centimeters for 1 inch. Equals, okay, centimeter to centimeter, cancel out. So the remaining unit now is only inch. Now let us try to check. The question. We are going to convert centimeter to inch. Since all centimeter units here are cancelled out and the remaining unit only is inch, this is now the equation that we need for us to convert this value into inch. Okay, next process. You multiply 10 centimeter or 10 to 1 inch, and basically it gives you 10 inches divided by 2.54. So you do the mathematics. Let us try to compute that. I will just use my mobile calculator. So 10 divided by 2.54, this results to 3.93. We'll just put the answer here. This is equals to 3.93 inches. So this is the answer for number 1. 3.93 inches. Okay, let's go to example number 2, 100 centimeter to meter. Of course, we'll go back to our conversion table and we will look into the unit centimeter to meter if there is a direct relation to these units. Where is meter? This one. And where is centimeters? Meter. Yes, we have a direct relation of meter to centimeter, which is this one. So we will use this standard relation now for meter and centimeter. So I will just switch to our webcam and put it here. Our basis now is given for every 1 meter. This is equivalent to 100 centimeters according to the conversion table. So to solve this one, we will do the same process for example number 1. So this is 100 centimeters times, for every 1 meter we have 100 centimeters. Treat the units as algebraic quantities. Centimeter to centimeter will be cancelled out. The remaining unit is meter, so this becomes 100 times 1 is 100 meters divided by 100. So 100 divided by 100 is obviously, this will be resulted to 1 meter. So the answer for that is 1 meter for example number 2. You can pause this video and copy this sample problem. So more of this will be coming to our will be uploaded, and I will be sending to you the link. And obviously, if you are already member of the Google Classroom, you will automatically be notified when all activities will be uploaded to that specific section. Okay, so these are now the steps in doing conversion factors, and this is exactly what you need to do when converting units one set of unit to another. So I just want you to apply this one, or if you have some strategy or approach in converting units, you can use that, but provide me the solution. You can use your own understanding on how to convert units, but be sure to show your solutions so that I could have to check. I could have also the privilege to check if either your process is, or your solution is correct or not. I will just have to add another concept also, or fundamental concepts that you need also to know for you to have a deeper understanding of the fundamentals of this lesson for week 1. This is not included in our module. We cannot find this one in our module because this is a supplemental topics that you need to know. How to combine scientific number, how to multiply, how to add, or how to subtract, and how to divide number that has been expressed in scientific notation. Okay? So for example, let's try or addition of scientific notation. Example, you can post this video right after my explanation so that you can copy, because you cannot find this in our module. So for example, we have a value or a series of number like this one. We have 3.2, for example, times 10 raised to 5, and this will be added to 5 times 10 raised to, or 5.1, let us say 5.1 to be pattern on the first series. So 5.1 times 10 raised to, shall we say, raised to 4. Okay. Now, in adding scientific notation, remember that it is just like an algebra. You cannot add x into y, but you can multiply this one. So just like in scientific notation, we cannot add or different exponents in scientific notation. For example, 5 and 4, we cannot add this directly, because for us to add this one, the exponent of this series of number the same or similar. So how are we going to do that? Obviously, we will have to reduce the lowest exponent that we have in the series. Take note of this one. You will have to convert, if the given number is not similar in exponent, you will have to make or rearrange that number so that the exponent will become similar. But to do that, all you need to manipulate is the number or the given number that has a smaller value of exponent. So in this case, the smaller exponent here is obviously the second expression here. So we will be manipulating this one so that we could convert this, or we could add one exponent to make it 5, so that this will be similar to the first expression or term. Okay, to do that, it's very simple. All you need to do is for you to add one exponent to the existing exponent, you really need to move this into the left as we have been discussed in our scientific notation a while ago. So I just have to write here 5.1 times 10 raised to 4. I will move the decimal point here. So this expression becomes 0.51 times 10. How many movement do we have? Only one. So you add that movement into the exponent. So this becomes 5. Now the expression now becomes 3.2 times 10 raised to 5 plus 5. We will now use this computed value here. This one. So this becomes 0.51 times 10 raised to 5. So the exponent now are the same. So for our first term, the exponent is 5. And for the second term, the exponent is 5. And we can now proceed to the addition of scientific notation. And to do that, we just have to copy this one. So this becomes 3 equals 3.2 plus 0.51, and we will just have to this exponent will have to be excluded on that term. So this becomes times 10/5. Now do not multiply this into that term because this is just an exponent showing that we can express like this. We can exclude the exponent because they are just the same. Or for you to make it understand well, we can also express this as 3.2 times 10/5 plus 0.51 times 10 raised to 5 and add this value. 3.2 plus 0.51, this will give you, try to use your calculator so that you can check our answer, because I don't have here a scientific calculator. If you have one, and you can recheck this one. So the answer is 3.71 times 10, copy the exponent, times 10 raised to 5. So the answer for this expression is 3.71 times 10 raised to 5. Okay? That's for addition of scientific notation. You can pause this video and try to copy this example for addition of scientific notation. Okay, moving forward. Let's go. I will in subtraction, the same result also, or the same process for addition. Addition and subtraction of scientific notation are the same process. So I will just have to discuss addition and because they are also the same process. So for addition and subtraction, you just follow that process or explanation. Now let's go for multiplication. I don't need to discuss subtraction. I will proceed to multiplication to utilize our time. Multiplication of scientific notation. For example, we have this value 3.5 again times 10 raised to 4 multiply to 3.5 times 10 raised to negative 6. So in multiplication, despite the value of the exponent, we can directly manipulate this one and proceed to the operation. So never mind either the exponent is the same or not the same in expression. Never mind that, and you can directly you can automatically proceed to the multiplication process. So all you need to do is, what we are going to do is just get this one and this one. So this becomes 3.5 equals 3.5 times 3.5. 3.5 times 3.5 times 10. So in multiplication, we will just have to add, sorry for that, I'm so full. In multiplication, we just have to add the exponent of the series of the expression of scientific notation. So in these terms, the exponent here is 4 and then the exponent here is negative 6. We will just have to add the exponents. So this becomes, exponent here is, exponent of that is 4 and plus this one is 6, so this is negative 6, and we'll just have to close this one. This is equals to, you multiply 3.5 times 3.5, this gives you 0.1225, and you do the operation here, 4 plus negative 6, this becomes, of course, negative 2. Or we can just write here to make it step by step. 3.5 times 3.5 times 10 raised to negative 2. So the answer is 0. Multiply this one, 3.5 times 3.5. The answer is 0.1225. Exponent is negative 2. So from this expression, we will move our decimal point in 2. So from this, we will move our exponent to the right. How many movements? 2. Since negative, so 1, 2. So this becomes 12.25 times 10 raised to negative 2. And this is now the answer for that problem. 12.25 times 10 negative 2. So that's how we multiply scientific notation. You can post this video for you to copy this example, and we'll proceed to the division of scientific notation. Okay, you can post this one. Now let's proceed to the division of scientific notation. For example, we have this value 5 times 10 raised to, shall we say, we'll just use negative value, negative 4 divided by 5 times 10, this time let us say negative 5, negative 4, negative 5, or negative 1, negative 1. So 5 times 10 raised to negative 4 divided by 5 times 10 raised to negative 1. So the rule here is just the same for multiplication. You will just have to, what are you going to do for the exponent? Obviously, we're going to subtract exponent for the division of scientific notation. For multiplication, you add the exponent, but for division, you subtract the exponent. How are we going to do that? So this becomes equals 5 over 5 times 10 raised to How are we going to express this one? Negative 4 minus negative 1. Negative 1. So 5 over 5 obviously is 5. This becomes 1. So you do the operation for this one. Negative 4 minus negative 4. This becomes, obviously this becomes negative 3. So the result becomes 5 over 5 times 10 raised to negative 3, or just be equals to 5 over 5 is equals to 1 times 10 raised to negative 3. So this is now the answer for this number. So division of scientific notation is here. You can pause the video and copy this solution. Okay. Now in summary, for multiplication of scientific notation, exponent should be multiplication of scientific notation. Multiplication of in multiplication of scientific notation, exponent must be added. For division, scientific notation, exponent must be subtracted. And for addition of scientific notation, exponent should be same. And add. Or no, copy, not add, copy. Same and copy. And for multiplication, division, for subtraction, addition and subtraction are just the same. Subtraction of scientific notation is exponent should be same and copy. So that's these are now the summary for each of the operation for scientific notation. Now, if you have some clarification regarding this discussion or this principle, you will have the freedom, or you can have me reach to our group chat, or you can directly message to my Facebook account. Thank you so much for your time. See you in the next video.